Good evening, students. Today we are going to continue our yesterday's topic, that is alkanes. Already we discussed what are alkanes, and we discussed some conversion methods of alkenes to alkanes, that is Sabatius and Sandrens reaction, and we have seen rate of hydrogenation and stereochemistry of that hydrogenation, and what are stereospecific and what is stereoselective we have seen, and in that two different type of cases we have seen, that is symmetrical alkanes and asymmetrical alkanes we have seen. While discussing about reductive hydroboration, because of some interruption our video is stopped yesterday. Now we are going to continue from there. Now yesterday already I said what is reductive hydroboration. Reductive hydroboration. What is reductive hydroboration? Addition of BH3. Okay, addition of BH3 to unsaturated compound is known as reductive hydroboration. What is unsaturated? Like double or triple bonds present between two elements is known as unsaturation. Addition of this BH3 to an unsaturated compound is known as reductive hydroboration. Let's see mechanism how it is. And in reductive hydroboration there are two types. One is reductive hydroboration, that is BH3 in the presence of THF in the presence of H plus. This is reductive hydroboration. And what is oxidative hydroboration? Oxidative hydroboration. The reagent is BH3 THF OH minus. Okay. Now if you see here tetrahydrofuran, that is THF is present. What is this use of THF? Okay. Let's see. In the absence of THF, what happens? In the absence of THF, this BH3 will start dimerize. Okay. This BH3 will react with another BH3 and it will start to dimerize like this. If it starts to dimerize, the reaction won't happen. We have to stop this dimerization. For stopping this dimerization, we have taken this THF, that is tetrahydrofuran. This is the structure of THF. This THF, what it will do, if we add THF here, what happens? Dimerization will stops. Okay, you understand, right? Why we are using THF over here. In both, in oxidative, either oxidative or reductive hydroboration, the use of THF is to stop dimerization. Let's see the mechanism, how the reaction proceeds here. Okay. See here, CH3, CH, double bond, CH2 in the presence of BH3. Okay, in the presence of BH3. How this BH3 is going to add over here? See carefully. In the next step, what happens? CH3, CH, single bond, CH2, BH2, H. If you see here, what I am doing right now here, I am doing all these bonds dashes. That is, this addition of BH3 is going through a cyclic transition state. Okay, that is 4-membered cyclic transition state. How many membered? 4-membered cyclic transition state. The reaction mechanism is processing through cyclic transition state. That is, this bond is forming. This dash indicates that this bond is forming, this bond is breaking, and CH bond is forming, and this double bond is breaking. Here it is going through 4-membered cyclic transition state, or you can say syn addition. Okay, this is also syn addition, like Previously we have seen in Sabatier-Sandrins reaction, it is also a syn addition, and here also it's an syn addition, or else you can say this is an anti-Markovnikov addition. Which addition? Anti-Markovnikov addition. That is, this substrate is added to the less substituted carbon side. Okay. In the next step, what happens if you see here? CH3, CH2, CH2, BH, H. Okay. Here this H form bond with CH, and this BH2 form bond with CH2. This H and BH bond is broken. In the next step, again one alkene is added. The same alkene is added. Okay. Now what happens? See, same, this reaction is again proceeding. This H is going to add over here, and this BH is going to add over here. In the next step, if you see, the reaction will look like this: CH3, CH2, CH2, B, CH2, CH2, CH3, and here H. Again, in the next step, another one alkene is added. Okay, CH3, CH double bond, CH2. Now what happens over here? This H is going to add here in more substituted carbon, and this B is going to add over less substituted carbon. In the next step, the product will be CH3, CH2, CH2, B, CH2, CH2, CH3, CH2, CH2, CH3. Okay, this is the product. Now we are going to see both oxidative hydroboration by this product on this product and reductive hydroboration. Okay, now we will see. I am rubbing all this, and I am going to see both oxidative hydroboration and reductive hydroboration through this product. Okay, let's see. If I write somewhat small letters, right, it is very difficult to see, so that's why I am writing somewhat broad letters and giving more gap. Okay, now if you see here, CH3, CH2, CH2, B, CH2, CH2, CH3, same, CH2, CH2, CH3. Now if you see here, first, okay, first we will see oxidative hydroboration. Okay, oxidative hydroboration. Here OH minus we will add. Okay, OH minus or H2O2. What happens for oxidative hydroboration? I am talking over here. Okay, what happens? Just break this bond, add OH here, another OH here. Break this bond, add OH here, another OH here. Break this bond, add OH here, another OH here. Okay, let's see the product. What is the product here? CH3, CH2, CH2, OH plus BOH3. It is the product for oxidative hydroboration. You understand, right? Here we added OH minus. Break the bonds. Okay, break these bonds and add OH on both sides, and the desired product will be this. The same for reductive hydroboration. Okay, this is for one. This is for one oxidative hydroboration. For second reductive hydroboration, we will add RC double bond OH. Okay, how this divides? H plus and RC double bond O minus. You understand, right? RCOOH is divided like H plus and RC double bond O minus. If you see here, now I am rubbing this OH. Okay, you understand, right? In oxidative hydroboration, you just break the bonds and add OH on both sides. In reductive hydroboration, this RC double bond OH is divided into H plus and RC double bond O minus. Now you just break this bond. Okay, add H plus over here and RCOO minus over boron. Okay, H plus here, RCOO minus here, H plus here, RCOO minus here. So in the reductive hydroboration, what is the product? CH3, CH2, CH2 plus H, that is CH3 plus B RCOO3. Okay, you understand oxidative hydroboration and reductive hydroboration. What we did, we just add BH3 to an unsaturated compound that proceeds through 4-membered cyclic transition state or anti-Markovnikov state or syn addition. Okay, after that what we have done, in the presence of oxidative hydroboration we break this bond, we added OH on both sides. In the presence of reductive hydroboration we divided this acid into H plus and RCO minus, we break this bond and added H plus to unsaturated compound to this alkane and RCO minus to boron. Okay, you understand, right? Now I am gonna give few examples. Okay, just pause the video and try it. Like CH3, CH2, CH double bond, CH2, BH3 or H plus, BH3 or OH minus, BH3 or D plus, BH3 or OD minus. Okay, pause the video and just try it. Okay, let's see. I'm gonna write the product. What happens here? CH3, CH2, CH3. Okay, in the next step OH minus, right? CH3, CH2, CH2, OH. Here BH3 in the presence of D plus, CH3, CH2, CH2, D. Okay, this is syn addition, don't forget. Okay, here OD minus, CH3, CH2, CH2, OD. Okay, you understand, right? Very good. Up to now we discussed two conversion methods of alkene to alkane. That is, first one is Sabatier-Sandrens reaction and the second one is reductive hydroboration. Now we will see third one, that is Wilkinson catalyst. Okay, Wilkinson catalyst. What is Wilkinson catalyst? That is PH3P3 rhodium chloride. What is the IUPAC name of this compound? Tris triphenyl phosphine rhodium chloride. Okay, here in this Wilkinson catalyst, it is a homogeneous catalyst. That is the reaction done in the same phase, and it is also an syn addition. Okay, it is also an syn addition. But here both alkenes and alkynes are converted to alkanes. Okay, here both either alkenes or alkynes converted to alkanes here. Okay, it is a homogeneous catalyst, that is the reaction done in the same phase. It is also a syn addition, remember this. Okay, we will further. Now the next one is another reaction, that is conversion of alkene to alkane, is diimide reaction, that is N2H2 or N2H4 in the presence of H2O2. Okay, N2H4 in the presence of H2O2. Just see here, alkene is converted to alkane. Okay, this mechanism is very simple. For example, you just see here CH3, CH double bond, CH2, N2H2. Okay, N2H2. What happens here? This double bond will abstract this H plus and this H minus will go and attack on this CH, and the product is CH3, CH2, CH3 plus N2. Okay, this mechanism is very simple, you understand, right? Up to now we have seen totally 4 reactions, that is Sabatier-Sandrens reaction, a syn addition, rate of hydrogenation we have seen, and stereochemistry of hydrogenation also we have seen, and second one is reductive hydroboration, how an BH3 is going to add an unsaturated compounds, and what is reductive hydroboration and what is oxidative hydroboration we have seen. Third one is Wilkinson catalyst also we have seen. The fourth one is diimide reaction, that is also a syn addition. In Wilkinson catalyst both alkene and alkane are converted to alkane, that is alkane conversion is completed. Now we will move to carboxylic acids. Okay, carboxylic acids. In carboxylic acid there are three reactions, that is first one is NaOH plus CaO. Okay, COOH, NaOH plus CaO converted to alkane. Second one is Kolb's electrolysis. What is this? Kolb's electrolysis. Third one is HI in the presence of red phosphorus. Okay, these are the three reactions where we are converting this acid to alkanes. Okay, first we will discuss about NaOH plus CaO. Okay, NaOH plus CaO. Do you know one thing? This NaOH and CaO is known as decarboxylating agents. Okay, decarboxylating agents. What is decarboxylating agent? That is removal of CO2 group. Okay, decarboxylating agent. Okay, here after seeing this NaOH and CaO, you have to think what is the use of this NaOH in the reaction, what is the use of this CaO in the reaction. Like this you have to think. Okay, for example, see the reaction CH3 CH2 C double bond OH, NaOH plus CaO. Okay, and another thing is here we are taking this in 3:1 ratio. Which ratio? 3:1 ratio. NaOH and CaO we are taking in 3:1 ratio. What is the use of NaOH here? This NaOH will abstract this H plus. Okay, remove this H plus. The use of NaOH is remove this H plus. Okay, remember this point. And what is the use of CaO here? CaO is used to maintain dryness in the reaction. Okay, CaO is used to maintain dryness in the reaction. After I am saying CaO is used to maintain dryness in the reaction, the first thing in your mind has to generate, why this reaction has to be prevented by water, why this reaction has to be maintain this dryness. Understand why this reaction has to maintain dryness. If you see in lab, I think in our chemistry labs you have seen NaOH reagent bottle. Okay, you have, everyone has seen, right? NaOH reagent bottle, some white pellets are there. If you take these pellets outside from the reagent bottle, what happens? Immediately it starts liquefying. Okay, immediately it starts liquefying. Why NaOH is started liquefying? Because NaOH is hygroscopic in nature. What's its nature? Hygroscopic. What is hygroscopic? Hygroscopic means absorbing the moisture from the surrounding atmosphere. You understand? This NaOH white pellets will start liquefying. Why? Because it is hygroscopic in nature. What is the term hygroscopic defines? Hygroscopic means absorbing the moisture from the atmosphere. You understand, right? If it absorbs the moisture from the atmosphere, what is the damage for this reaction? So we are doing this reaction in the presence of dryness, right? CaO is used to dry the reaction, right? Why we are preventing this water from this reaction? Because I already said we are converting this carboxylic acid to alkane. That is, this CO2 group is decarboxylating group here. That is, CO2 group is removed over here. You understand, right? If this hygroscopic nature is present in the reaction, if this hygroscopic nature is present, then this hygroscopic nature of sodium hydroxide react with this decarboxylating agent, okay, and some undesired products will be obtained. So for obtaining the alkane product from acid to alkane, we have to prevent this hygroscopic. We are preventing this hygroscopic by using this CaO. You understand, right? Why this NaOH is used, why this CaO is used. The CaO uses dryness. Why dryness is necessary in this reaction? What is the nature of sodium hydroxide? If it is hygroscopic nature, then what is the damage for the reaction? Okay, you understand everything, right? Now we will see the mechanism of this reaction. Okay, I already said NaOH, that is how it divides. Na plus OH minus. You understand, right? Now if you see, this OH minus will abstract H plus, and what is the reaction? What is the next step here? CH3 CH2 C double bond O minus Na plus. Okay, understood, right? In the next step, what happens? Decarboxylating agent, that is CO2, will be removed. Okay, how CO2 will be removed? This bond migrates here and this will go here. This bond will be here. In chemistry, remember one point: for single electron transfer, you have to show the arrow like this. Okay, for free radical reaction or single electron reaction, you have to show the arrow like this. That is a fish hook arrow. For both two electron is transferring for at one side, that is you have to show like this. Okay, remember this point. Now what is the next step? CO2 is removed here, so CH3 CH2 minus. You understand, right? CH3 CH2 minus and Na plus. Now what happens in the next step? H2O is added. Okay, H2O is added, that is it is divided into H plus OH minus. In the next step, what happens? CH3 CH2 CH3, and this will take this H plus. And remember one thing, this is very important thing: always show the movement of negative ion to positive side. Okay, always show the movement of negative ion to positive side. Okay, this is correct. Don't show the movement of positive to negative. This is wrong, because it has vacant, that is it is vacant, it don't have electrons. When there is no electrons, where the movement come from? Okay, show this negative to positive, that is correct. Okay, these are all the basic things, but very important things. Okay, what is the next step here? Sodium hydroxide. Okay, sodium hydroxide. If you see here, this reaction is proceeding through carboanion. Okay, this reaction is proceeding through carboanion intermediate, that is rate of reaction is directly proportional to. Okay, rate of reaction is directly proportional to stability of carboanion. Okay, stability of carboanion. After seeing this carboanion, we can say that is no rearrangements are possible. Okay, no rearrangements are possible. Remember these points. You have to keep in mind this mechanism, then only you can know that this reaction is proceeding through carboanion mechanism. In carboanion mechanism, there will be no rearrangements are possible. Okay, if you see one thing, if this carbon dioxide is not removed from the reaction, what will happen? Okay, if this carbon dioxide is not removed from the reaction, what will happen? Then it is again reversible, that is this CO2 will attack CaO, and what will form? CaCO3 will form. Okay, CaCO3 will form. Let us see some examples for this reaction. COOH, COOH. Now just remember, you know the mechanism behind it. What happens? It is a decarboxylating agent, that is this CO2 is removed. Simple, if you remember that all mechanism, right, you can just write like this, no need of mechanism every time. Okay, here two COOHs are there, that is NaOH plus CaO, 3:1 ratio, that is this COOH groups are removed from the reaction. Okay, for example, see this, what happens now, this COOH is removed. Okay, HDCH3. Okay, in the next class we will gonna study about another Kolb's electrolysis and HI in the presence of red phosphorus and conversion of carbonyl compounds we will study, and conversion of alkyl halides we will study. We will study about physical properties, we will study about chemical properties of alkanes, that is halogenation, sulfonation, isomerization, aromatization, all these we will study. And then after we'll study about what is knocking and anti-knocking agents, what is octane number, what is centane number. We will study all about this. Okay, thank you students, please like, share and subscribe.